This is part 2 for my video on mathematical relationships between pressure, volume, temperature, and N, your amount of particles. Now, earlier on the other side of this problem, or the other side of this page, we saw examples where we were changing one of our variables and we saw the effect that it had on a different variable. Well, now we're going to make it a little bit one step harder. We're going to look at multiple variables and that effect. So on our next example, a sample of sulfur dioxide occupies a volume of 652 milliliters, 40 degrees Celsius, and 720 millimeters of mercury. What volume will the sulfur dioxide occupy at STP? A lot of information here. Let's plug it into our chart. So I'm occupying a volume of 652 milliliters. That's the starting amount that I'm given for my volume. I'm starting at 40 degrees Celsius, but again, this is degrees Celsius. I have to have it in units of Kelvin. So in order to go Celsius to Kelvin, I need to add 273. 40 plus 273 gives me 313 Kelvin. That is my starting temperature. So I'm going to put that as my initial temperature. I'm also given 720 millimeters of mercury. That's going to be my starting pressure. Cool. There's my initial information. What volume? Okay, so I'm trying to calculate my volume. That's what I'm trying to find. So I'm going to put my question mark for my volume. Will the sulfur dioxide occupy at STP? Now on the other side, we saw that STP was standard temperature and pressure, which was 0 degrees Celsius and 1 atm. And again, your 1 atm could be equal to 760 millimeters of mercury, 101.3 kilopascals, 14.7 psi. That's standard unit. That's standard amount. All right, so let's take my STP. It's 0 degrees Celsius. Let's convert that into Kelvin, because I need it in Kelvin before I can plug it into this chart. So 0 plus my 273 gives me 273 Kelvin. That is going to be my final temperature. My standard pressure is 1 atmosphere. Well, the units it gave me were millimeters of mercury. But I know that 1 atmosphere is equal to 760 millimeters of mercury. So I can use that as my standard pressure, 760. I don't have anything about the amount of particles, so I'm not going to worry about my N value. Okay. Just like before, we need to see the effect of what my pressure is doing, what's my temperature doing, and then I have to relate that to my relationships to figure out what my volume is going to do. So my pressure started at 720, it went up to 760, so that means that my pressure was increasing. My temperature started at 313, it went down to 273, so that means my temperature decreased. Now, what's going to happen to my volume? Well, there's two different relationships. One that relates pressure to volume and one that relates temperature to volume. So I have to see the effect of both of them. What I'm going to do is I'm going to split this box in half. And I'm going to look at what my pressure does and what my temperature does to my volumes. Let's talk about my pressure first. If I increase my pressure, well, this is an indirect relationship. So if I'm increasing my pressure, that means my volume is going to decrease. So here, increasing pressure, my volume is going to decrease. Now my temperature, I'm decreasing my temperature. If I look at my relationships, it's a direct relationship. So by decreasing my temperature, that's going to cause my volume to decrease. All right, so my pressure should decrease my volume, as well as my temperature should decrease my volume. Now let's figure out what my volume would be. Let's calculate it. So let's start with my initial amount of volume, 652 milliliters. Just like before, I'm going to need one of my variables, set it up as a factor in order to get my volume to have this particular effect. It does not matter which variable you look at first. I could use pressure here, or I could use my temperature here. It would not matter. I'm going to use my pressure first because it's the one that comes first in my table. So, my pressure should cause a decrease in my volume. That means that my larger number, my 760 or my 760 compared is larger than my 720. That means that my larger number should go on the bottom. So 760 millimeters of mercury and my 720 millimeters of mercury on the top. If I plug this in, it should give me a smaller volume than 652. So 652 times 720 divided by 760 equals 617.68. These units canceled. I'm left with milliliters, units of volume. Perfect. This was smaller than what I started with, and that was what my prediction said should happen. That is just the effect of volume based on the pressure change. I also have to look at the effect of volume based on the temperature change. So this next step, I need another factor. And this time I'm going to look at my temperatures. So again, my temperature should decrease my volume. In order for this number to get smaller, I need my 313 on the bottom and my 273 on the top. So my 617 times 273 divided by 313, that should be lower. Well, that's what my prediction was, 538.7. My Kelvin cancel. I'm left with milliliters. That is smaller than this value, which was smaller than this value. So both of these effects decreased my volume. Perfect. Let's round to significant figures. I started with 3 significant figures, so my answer key would have 540 milliliters. Excuse me. My 7 causes my 8 to round up, so 539 milliliters. There we go. That gives me 3 significant digits. 539 milliliters. Let's try one more example. The initial temperature of a 1 liter sample, all right, I'm given 1 liter, that's a unit of volume, so that's my initial volume. My temperature is 20 degrees Celsius. I don't want to keep that in Celsius. I need to change that into Kelvin, so I'm going to add 273. I get 293 Kelvin. That's my initial temperature. The pressure is decreased from 720 millimeters of mercury to 360. Okay, it gives me a lot of information here. It's decreased from, which means that it's starting at this first value. So 720. And it decreases down to 360. Hey, they already told you that this was decreasing. That's cool. Now we don't have to think about that. Says my volume increases to 214, so it's going from 1 liter to 2.14. And that was an increase in my volume, so there's my little up arrow. It it wants me to find the change in temperature of my argon. So I'm going to try to find that final temperature. Now again, what type of effect does my pressure have on my temperature? And what type of effect does my volume have? Well, for my pressure, temperature and pressure are directly related. So a decrease in pressure would cause a decrease in my temperature. My volume and my temperature are also directly related. So my increase in volume would cause an increase in temperature. Pressure is causing it to decrease. My volume is causing it to increase. So we're going to try to find some number that's different than my 293. Let's start with my 293 Kelvin. Again, it does not matter which of these we use first in our factor. It won't matter as long as you end up using both of them eventually. So I'm going to start with the pressure just because it's the first that comes in the column. My temperature should decrease according to my pressure. So in order for this to decrease, I need my 720 on the bottom and my 360 on the top. Just to double check, let's plug that in. So if I take 293 times my 360 divided by 720 equals 146.5. Millimeters of mercury canceled out. I'm left with Kelvin. That is a smaller temperature than what I started with. Great, because that's what I predicted would be the effect from my pressure. Now, my volume is going to cause this value to increase. So when I set up my factor, I need to set it up so that this value is now higher. So that means that my 2.14, my larger number, is going to go on top. My 1.0 is going to go on the bottom. My prediction is that my temperature should be larger. Let's make sure that my math matches my prediction. 146.5 times my 2.14 divided by 1 equals 313.51. My liters canceled out. I'm left with units of K. That's bigger than what this value was. Well, that's good because I predicted that my volume should increase my temperature. And this is my answer. So let's round that to appropriate significant figures. I started with 3. So if I round this to 3 sig figs, I'd have 3, 1, and then the 5 would round that up to a 4, 314 Kelvin. Hope that was helpful. A lot of math, kind of confusing, a lot of ratios that we're thinking and proportions. Please, please, please come in and see me. If you are struggling with this, you want to meet one-on-one to go through it. I would love to help you out. Hope that was helpful. Please see me for questions and have a great rest of your day.